Okay, so now we're going to have a panel on the Mars Arctic 365 mission. Would the three panelists please come up? Sure. That includes Carol Stoker and Gene Hunter and Shannon Rupert. Okay. So, as everyone here knows, the Mars Society has built and operated the first two Mars analog research stations, starting with the Flashlight Station on Devon Island, which we built in 2000, and operated starting in 2001, and then the Mars Desert Research Station, which we built in the winter of 2001-2002 and started operating in the spring of 2002. To date, we have had over 130 missions at the Mars Desert Research Station. Almost all of them 2-week missions. However, there have been at least 2 one-month missions there. And at the Flashlight Station in the Arctic, we had a number of short missions ranging from 4 to 10 days, and then I believe 5 one-month missions and 1 4-month mission. So in total, we've had about 140 missions. Over 800 people have participated in one mission or another at one station or another, which is just spectacular. And the desert station is going on, and in fact, if you want to participate, there is a call for volunteers posted on our website right now. But we've learned a great deal from these short duration missions. There's a lot you can find out about what is likely to work on Mars and what is not likely to work on Mars in a 2-week mission, and what crew combinations are likely to work well and what are very unlikely to work well. But still, we're going to be on the surface of Mars for a year to a year and a half, and that is a tougher thing. And in order to do a true dress rehearsal for human Mars missions, we need to, at some point, do longer missions. And our most realistic station, vis-a-vis Mars, is the Flashlight Station on Devon Island. It's in a polar desert, okay, which has a meteor impact crater in it, which has created shock terrain and all kinds of geological phenomena which are believed to mirror those that exist on Mars, and that's why some NASA scientists have repeatedly gone up there to try to learn about Mars through geological comparisons. And it's why we decided it as the location of our first station, okay, so that we could send crews there and attempt to conduct a sustained program of field exploration in this polar desert, with the crew being constrained to operate as much as possible as if they were on Mars, and by so doing, learn what's likely to work on Mars and what isn't, okay? And it was suggested to us that it was time to advance this program by attempting a long-duration mission, a 1-year mission at the Arctic Station. And this is incredibly challenging to do, okay? Believe me, the station is extremely isolated. It is on Devon Island, which is an uninhabited island. It is, in fact, the largest fully uninhabited island in the world. It's about the size of Ireland. Okay, the closest habitation is a small settlement known as Resolute Bay, about 150 miles away. It's got a population of several hundred people, mostly Inuit. The access to the island is through Twin Otter or comparable Bush aircraft, and if you need one, it might not be available for several days, and that's even in the summer. In the winter, it could be much tougher. So the crew will be isolated, and if one was to just think about this, okay, there recently was an experiment that most of you have heard of called Mars 500, in which they isolated, as it were, a crew in a room in Moscow for 500 days, okay, which is longer than a year, yes, but they're in a comfortable room, playing chess, reading novels, not in any danger, not being forced to try to get real scientific work done, okay, not trying to do field work of any kind, let alone in spacesuits, not putting up with the constant failure of bulky equipment, not attempting to conduct a telescience collaboration with an Earth-based science team, you know, and just not having to put up with the stress of that and danger and weather and all kinds of other things that a crew would face on Mars. But yet, this is what we're going to try to do. So this program has been initiated. This past summer, we had our first, preparatory thing. We had not been up at Flashlight Station since 2009, and we had to assess the condition of the station before we could attempt to raise serious money for this mission. We had to know we really still had a station. And then we anticipated that also there'd be a number of important improvements that need to be done even to the station as it was. So we sent a crew up there. It was led by Joe Pelea, and we were greatly assisted by two volunteer pilots who owned Kodiak Aircraft, which is an outback kind of aircraft suitable for Arctic operations, and they contributed their time, their aircraft, they bought the fuel, and they did logistic services for us and made this possible. And we went there, we found the station was still mechanically sound. There's a few things that are in rough condition and we would want to replace before we initiate the sim, but they're superficial things like the carpet and the cabinets. We were able to bring in various equipment, all-terrain vehicle, a new generator. We were able to determine that the old generators were still operational. The old comm system was still operational. The old weather station was not operational, but we brought in and established a new one. We opened up 2 new airstrips to give us greater access regardless of wind directions. We did a lot of, and we moved a great deal of material all the way up either to the island or to be staged in Resolute Bay. The plan right now is that there'll be another work crew sent in next July to finish the upgrades that are needed, and then hand the station off to an actual simulation crew in August to begin a 1-year sim there. This is contingent on a lot of things going right, including fundraising, aircraft being available, and the right volunteers stepping forward to constitute a first-class crew to do this mission. But nevertheless, we intend to go ahead with this. Okay? So there's a lot of things that can be learned from a mission like this, and so the people on this panel, along with me, Shannon Rupert, Gene Hunter, Carol Stoker, are all involved in one way or another, mostly with the science team. Certainly Gene and Shannon is also running the Mars Desert Research Station program right now and has a great deal of experience. So I invite comments from the other panelists, and perhaps with Carol, on what they see us accomplishing with this mission.
Okay, so you caught me off guard.
Well, if you want one of the other ones to go first.
Yeah, Shannon, why don't you go first? Shannon's been running the Mars Desert Research Station science program, so maybe has more insight into what might be more useful to do over a longer duration, because the MDRS crews are 2 weeks typically.
Right. One of the things that I think is really important about the Mars 365 mission is we have done short duration missions to death, and we've probably forgotten 50% of what we've learned over the past decade plus in terms of what we really need to have a successful Mars mission. So Mars 365 is going to give us the opportunity to take all that generated knowledge and kind of distill it down into an actual mission plan that we can use. And from the science perspective, we're all really excited, but we actually haven't met as a science team.
Right. This is our first meeting.
This is our first meeting. But I would imagine that we would, of course, part of our focus will be on looking at what we've learned on Mars itself and focus on what we can learn here on the analog of that. And I mean, it is really true that we don't have a strong science plan. I do know that we want to build on what we've already done, and the team is larger and more diverse than it's been in the past. So it's going to be pretty exciting when we actually have a plan.
Okay, well, you have also put together a rather large team in support of the desert station.
Yes.
Do you see bringing part of that team to bear in support of Mars Arctic 365?
Definitely. One of the things that we discussed and decided was that those mission support people and crew people who have served at MDRS were, again, a wealth of knowledge and information and skills that we wanted to translate to things that we were doing at FMARS. And so, although we have a designated science team that will be leading the science plan, we also have an additional remote science team at MDRS, an engineering team, an astronomy team, a green hab team, a bunch of different teams that will be supporting Mars 365 in whatever capacity they can. So it's kind of exciting and it's kind of chaotic at this point to not know how to translate those of us who have been working at MDRS to Mars 365. But these teams have been working together for years, doing exactly what we want to. So the mission support teams actually are the longest duration Mars analog people we have. You know, they don't just go out to the station for 2 weeks or a month or even 4 months. They've been in the trenches, so to speak, for years. And so we have a really great base to do this successfully in our mission support teams as well.
Jean, you got some comments?
Well, Shannon is correct that we have a really wonderful set of scientists. How do I turn this on?
No, just move it closer.
It's on.
Is this better?
Yes.
So, okay, thank you. Shannon's right that we have a really great set of people working with us both on the mission support side and on the remote science team side. And in fact, last year, under Shannon's direction, the remote science team was pretty much rebuilt. We added new people, new responsibilities, and we also initiated a higher set of standards for the scientific work that was done at MDRS, making us all better critics and better supporters of good science, better helpers or assistants for good science at field stations like MDRS and FMARS. My role at MDRS has been in mostly the food aspect of life support, but professionally I work in other aspects of life support as well. And among the studies that we may do, in addition to field studies, would be studies of microbiology, for example, the gut microbiology of the crew, microbiology of the habitat itself, things pertaining to, for example, food safety or nutrition, the performance of the habitat, things like the heat or the thermal profile of the habitat, the efficiency of the generator, the temperature and humidity distribution, the habitability factors in the HAB, all of which will be important to understand so that we can account for, and so that we can learn to predict any problems that might come up and learn to fix them as they come up. Let's see. Another thing that we need to do looking forward to the MA 365 mission is there's an awful lot of planning that has to take place. There's going to be consumables, there's going to be equipment and redundancy. There have to be plans for what to do with equipment breakdowns and failures. Robert is correct that any long-term mission is going to experience equipment breakdowns and failures, but how can we best support quick repairs and effective repairs on the part of the crew? So we're going to have to plan our supplies and our tools and the kind of training that we give the crew. And we're also going to need, I think, an outside consultancy of engineers, mostly from the MDRS engineering and troubleshooting staff, to help the crew solve the problems that are going to come up as they move forward in their mission.
So I actually have an engineering question, because this literally is our first meeting. So it seems to me like a serious challenge about doing a year-round stay in the flashline habitat is, how do you stay warm in the winter? Because it's going to be, very cold. And at Mars Desert Research Station, even as cold as it gets there, I mean, there's a heating system. And as far as I know, no heating system has ever been installed in Flashline.
Yes, good point. What we're installing is a system that takes the exhaust from the generator and uses it as a source of heat for the HAB, okay?
So it's a heat exchanger solution.
Really?
That's right.
Sounds like carbon monoxide
Yeah.
poisoning.
No, no, it's through heat exchange. We're not going to plumb the exhaust into the head. No, although that would be very efficient.
Yeah.
That would be the most efficient system. But no, we are going to put up with a small amount of inefficiency to heat exchange between the exhaust and a working fluid, and use the working fluid to warm the HAB. Now, it won't be as comfy as the Mars Desert Research Station, in which people can regulate that and have, 70 degrees in the HAB. The temperatures may vary, and they may be more like 50 Fahrenheit in the HAB, and people have to walk around wearing, thermal underwear and sweaters and so forth, and woolen pants. But it should be acceptable. And that is the system that we're installing in there, okay? And we have actually 4 generators, so that we're multiply backed up on this. Okay. So, and then in addition to that, there are auxiliary propane heaters, but we don't want to use them because, unless it's an emergency, because they do release water vapor into the HAB, and that causes issues. So, but they're there as an emergency backup.
And how are you going to prevent polar bears from eating the crew? That's my other major question.
Using firearms.
We're going to get them before they get us, which is always the goal.
Okay. Let me just comment on a couple things. The science program has yet to be worked out in detail, or even in full broad brush, but a few things about it can be said. First of all, the bread and butter is to be conducting field exploration in geology and microbiology, climatology, doing many of the same tasks in the field as a Mars crew would do, except, and doing it in the same way. We have these simulated spacesuits so that when you go outside, you have to wear them and do your exploration in that fashion. And then, while doing that, we're going to be attempting to develop a new art. We've been working on this already for some time at the Desert Station and in the previous Flashline missions, but this will really put it to the test, which is what I call telescience, okay, where you've all heard of telemedicine, where you have a general practitioner in Alaska and he has to do a heart transplant, and the people at Mount Sinai in New York City are walking him through it. You know, first you grab this one and you grab that one and you tie them together, and you do it. Well, the crew on Mars in a Mars mission is going to be general practitioners, okay? But they'll be backed up by a remote science team on Earth containing all the different specialists with all the disciplines, and they're going to have to work in a collaboration. This is not how, for instance, geologic field work is currently done on Earth at all. Okay, there it's when the professor goes out to the country with his grad students in the summer. They collect their samples, they bring it back to the lab, they work them up. 6 months later, they send a paper into a journal, and a year after that, it gets published. And then people find out what they saw. That's not how we're going to do Mars. Here, it's going to be ongoing collaboration with the reporting back the raw data, getting advice from the backup science team is where they take this next, or where they or how they might interpret it, and all that. So we're going to be basically developing or experimenting with developing, but in a very serious way, this art of telescience, which is fundamental to the Mars mission operation. Now, we do have some problems here, though, in the fact that during at least half the year, much of the landscape is going to be covered by snow, which will interfere with geology, for example. But there are other things that can be done in the Arctic, and this has not been settled at all because it needs to be discussed. But one thing that I favor is bringing a telescope, okay, to the station. And even though astronomy is not a major activity that would typically be expected of a Mars crew, it is an activity of comparable technical difficulty to other tasks that they might be asked to perform. And given that we're in the Arctic and it's going to be night for 5 months straight, we're in an ideal situation to do astronomy. And we've got some good astronomy at the Mars Desert Station already, and so that's been part of our program there. But here we could do astronomy of a type that people ordinarily can't do on Earth anyway. You know, 4 month, well, we're not going to do a 4-month exposure on any particular target, but we could do a 24-hour exposure and or things of this sort. And I think that this might be a very good activity to do during the winter, and also one that has tremendous outreach potential. But anyway, there's all sorts of other ideas for the science content of the mission that will have to be put together and figured out and prioritized.
So it seems to me like this is another opportunity for crowdsourcing the mission design or the science design for the mission, because you know, one of the things that I did one of the first crews at Flashline Station, and it was one of the only crews that had a very active science backroom activity, and that was a very different flavor of science backroom activity than I've seen happen at MDRS, because the science backroom was very actively and in real time sending the crew out to do particular tasks. Then the crew was reporting back to them with the results of those tasks. You know, dialogue was going back and forth, data, images. You know, go to this site and take these images and get the following samples and bring back and give us the results. And it was very much an interactive thing. What it required was a lot of work and a lot of attention on the part of the science backroom participants, and a lot of compliance on the part of the Mars participants. And there's, very definite conflicts of interest that erupt right away. So, you know, you almost need a full-time psychologist just dealing with that, because the crews immediately think that each other are jerks. You know, I mean, the backroom crew
It's a
thinks
serious problem. I
it's a
mean,
very
it-
serious
it
problem, and
is.
it's a real problem, and it's a
Yeah.
real problem that will be experienced on real Mars crews.
Yes.
So how to deal with that, to me, is actually one of the most important problems to solve. And as I understand it, the 4-month crew similarly had issues like that.
Yes.
I wasn't part of that, but I know
Yes.
Shannon was.
So 2 examples of how this works well and how it doesn't work so well is, we did a project back in, 2003 to 2005 called Mobile Agents. I don't know how many of you remember it. And Telescience worked amazingly well on that project. It was out of NASA Ames because everybody was committed to it. The crew was committed, the remote scientists, so the earthbound scientists, those of us who were not on site, and were just as committed time-wise, just as committed in terms of wanting it to be a success. When we ran our field trials, it was a 24-hour-a-day thing. I would have meetings at 2 o'clock in the morning so that the guy I was meeting with in England we could sort of communicate with each other, because we'd have to get our analysis of the results and what we suggested, because it's a Mars crew, so you want to suggest what the crew does next. This is not your Apollo type back room where the astronauts have no idea what they're doing. It's more of a collaboration, and so we'd at 5 o'clock in the morning they'd get back. We think this is what we think the results of what you did yesterday were, and this is what we think you should do today. Sometimes they would do it, sometimes they wouldn't. They would say, well, we're going to try this instead. But this was a year's worth of work before we did a 2-week field trial, and every single person on both sides of the coin was committed. What we find a lot of times with shorter-term crews and teams that don't get to work together a lot before they actually go into the field is you get what Carol's talking about. You get the complete, it's magical in a very, very bad way. It's like you all can get along and agree until we send the astronauts to the Mars analog, and then all of a sudden they can't agree on anything. And we don't want that to happen when we go to Mars. It's going to be a much more serious issue if we actually land a party on the red planet and we can't, and they say, we're going to do what we're going to do and we're not going to tell you what we're doing. So for me, for years, remote science, telescience has been this huge, huge challenge, and it fascinates me still. And it's a huge passion with me, because I think there are 2 things we need to master before we can send a crew to Mars and expect them to do science with scientists on Earth. First, we need to learn to communicate, and believe me, that's hard enough. It's really, really challenging to get the earthbound scientists to communicate correctly with the Martian scientists and vice versa. But you have to get past that before you can start to collaborate. And it's really, really, really difficult to get to the collaboration part. So part of this mission for me, which is going to be very exciting, you did mention the 4-month. We had serious issues with the 4-month, and we weren't able to master it. We were not able to get past this. Now we have a whole year, and we have enough time to take our science team and our crew and hopefully take everything we've learned about what works and what doesn't work and put it to practice on a very, very, on the longest time scale that we've had so far.
Now, this phenomena is known by various names. I tend to call it crew-ground disconnect, because it means that the crew and the ground, it doesn't blame either one of them, but it focuses on the need to connect them back up. And what we have found in past experience at MDRS and other analogs, is that training the field team and the science backroom team together over an extended period of time to develop trust and a shared commitment to the work is really essential. The other thing that's really important is to have a low drama quotient on both sides. Okay.
How do you order that up? We need low drama quotient.
How do you order that up? Part of it is crew selection procedures, and part of it is training your ground control people to take a deep breath before responding, to check with each other before responding, to ask each other, am I reading this right? And to ask the crew, should I be, are you, am I detecting the correct message in what you just told me?
Are you really saying what I think you're saying? No.
Yes, but quite a bit more diplomatically. And we've seen several instances of crew-ground disconnect happening because the science backroom wasn't sufficiently well prepared, because the crew was surprised to be given what they perceived as additional tasks, unexpected tasks. And we've also seen these things being resolved after usually after more delay than either side is quite happy with, through a process of disclosure and negotiation on each side, and then diplomacy between the two sides, knitting the team back together again. So I agree this is going to be really interesting to test. I think sometimes the smallest problems, the smallest issues create the biggest problems because of the unexpectedness factor. If you know that you're asking a big favor, you tend to be quite gentle and pleading about it. Whereas if you want them to do a little thing that you know is not going to be a big deal, you tend to just toss it off. And the crew will do this too. So this is one of the things that we'll be. I don't think we'll be struggling with it as much as just wrestling with the challenge.
And we also won't have the option to do what we would often do in a 2-week rotation, where you can say, you know what, just let it go, because this is almost over and we can survive. With a whole year-long mission, we will be able to iron out and at least explore what causes these and ways to fix these disconnects that we have, which is cool.
Are there questions? Over there, sir, right here. Who's got the mic?
Anybody?
I've got a couple of questions. One, of course, is how you do telescience. Do you use broadband communication? If so, how do you do it? Off to a satellite, so forth?
Yes.
What broadband is your...
The link we have there is about a megabit a second satellite link. Now, and in general, okay, if you're in SIM, the communication's email, okay, not IMing or anything of this
Okay.
sort. In general, with email communication, it's not necessary to put in a 10-minute time delay because it usually happens anyway. And I'm not joking, that's just how it would. Email conversations tend to be kind of like conversations to Mars because you get an answer back about 10 minutes later, but sometimes quicker. But I think on this mission, at least after it gets started, we will implement a 10-minute time delay protocol on answering email, so there will be that time delays simulated as well.
Yeah, that was my next question. Then the third question really deals with the crew composition. Are you going to go through any process for the crew, bringing the crew together? Early on, I think you did that sort of thing. I haven't been able to keep up with you lately, so I don't know if you're still doing that sort of thing in terms of a crew matching.
Well,
kind
we
of
will. This is going to be a very serious crew selection process because, as Shannon said, we don't have the luxury of saying, oh, well, this crew didn't work out. They're not doing anything and they're a pain, but they'll be out of there in 4 days, so what the hell, live with it. No. And furthermore, the kinds of things that could happen in the Arctic are much more serious than what could happen in the Utah desert. And so we're not going till we have the right crew. And we're going to put out a call for crew volunteers. We're going to want to have people not just with scientific backgrounds or engineering backgrounds, although those are important, but Arctic experience and with character types that we think will be up to the challenge. And then we will bring them together. We certainly will meet with them, but I think we should probably do at least a short duration sim at the desert station with them because also, I mean, a lot of pathologies that are there can come out in 2 weeks. It really can. So at least we can, if we have an obvious problem, we can get rid of it and make changes. But yeah, this is going to have to be approached in a thorough way, and we intend to do so.
My final question deals with telemedicine. Are you set up to do anything like that? You have a doctor on the crew. Obviously, you might need specialists and this sort of thing. Emulating the Mars mission itself. Do you plan to do anything like telemedicine?
Well, look, we do aim to have someone in the crew with medical experience, although I do not anticipate having anyone in the crew whose primary assignment is as ship's doctor. Hopefully, those skills will never be needed. If they do have to be used, it is most likely that they'll have to be used with things like accidents, falls, broken limbs, you know, polar bear bites, things. Things of this sort. I mean, I don't anticipate attempting heart transplants, you know, in the station. And if we get a complex problem of that sort, we'll break SIM and bring in a Twin Otter and fly them out to Resolute Bay. But we will have someone in the crew to deal with the more ordinary kinds of medical situations.
Any imagery transmission capability?
Yes.
We have a dedicated group of flight surgeons. They're all medical doctors, and we have a telemed system that works for MDRS that will implement in the Arctic as well. So they'll have 24/7 availability of a physician.
Those will be still images, not video. Bandwidth is higher.
Well, it'd be crude video, but we're not going to do something where we try to walk somebody through an
Yeah.
operation.
Yeah.
Okay, we'll
break
have some.
them and get them out of there.
Yeah, I mean, look. Here's our hierarchy of priorities, and this also holds true in the desert station. Okay, number one is safety, in the sense that if a true safety situation develops, we break SIM and deal with the safety situation in the most practical way possible. Okay, in other words, we don't play astronaut when somebody, you know, has had a severed limb and is bleeding, and you know, he's like, well, you know, I'd like to help you, but I'm wearing a spacesuit now, so sorry. No, we just deal with it. Okay, that's number one. The second is the SIM, second priority. Okay, which means that if you could accomplish, you know, you could reach between the rocks and get that really cool sample if you just took off your spacesuit glove, you don't do it. Okay. You come back the next day with an appropriate tool to get it out. You accomplish the science objectives within the constraints of SIM. The third priority is science, okay? Because unless you're trying to do science, there is no sim. In other words, if you're not trying to do meaningful objectives, then you're just space camp, okay? But the deal here is this. You try to do the science objectives within sim, and my analogy is that of target practice. The object of target practice is not to put a hole in the center of the target. You could do that more easily by putting the target on the table and stabbing it in the center, and you would get a bullseye, okay? The idea is to do it where the target is 200 yards away, okay? Because by so doing, you learn marksmanship. So by learning how to do science with the target 200 yards away in sim, that's how you learn how to do science on Mars, okay? So that's the hierarchy. And then the fourth after that is public outreach, and the fifth is comfort. Comfort's right up there, it's number 5. So that's how it is.
So I have another question.
Okay.
And pretend like I'm in the audience. So
That's a very good question.
yes,
Are there any other
the
questions?
U.S. Antarctic program basically does 1 year tours of duty in the South Pole Station every year. When you go in to the South Pole Station, you actually have to stay a full year. So there's crews every year that go to the South Pole Station, and if they have an emergency, they can't get out. There was a woman a few years ago who got breast cancer. She was the crew's doctor, and she had to treat herself for breast cancer because they can't fly in there and get you out. So how is what we're going to do different or better than that? Because they are doing real science. They are stuck there for a year. They are under sort of, telescience directives. Everybody's got a project there, but they're not unsupervised.
Well, we'll be doing a sim. That's one important way in which it's quite different. And how large is that crew at the South Pole Station?
It's not very
And during the
big.
winter, it's something like 10 people.
Yeah, it's
not
not
a
a
lot
huge-
bigger.
Okay, well, it's somewhat bigger.
No, some crews are big. But the
Okay.
winter
I mean,
crews are
look,
small.
I read the book Bold Endeavors by,
Jack Stuster.
right,
Good job.
okay. Now, and that's a very good book, but it comes to certain conclusions based on studies of basically Navy enlisted men at the South Pole, okay, that are diametrically opposite of what we have found. Okay, in that, for instance, it finds that the number one problem that they suffer from is boredom. Okay, whereas we find the number one problem is overwork. Okay, and that is because of who the crews are and how they conceive what they're doing. Those Navy crews at the South Pole are enlisted men. They'd much rather be in San Diego on the beach, on the dock, and they're waiting for this to be over. Our crews, when we get them up to Flashline Station, they've been waiting to do this. They want to be there. They're driven. Sometimes they're somewhat in competition as getting their science program done because the other one is hogging the time and resources of the crew. During my cruise up there, I repeatedly had to order the crews, and I mean order the crews, to stop working at 9 p.m.
I've
Okay.
had that problem in Antarctica.
And so it's a different demographic. I think our demographic is much closer to that, which would actually go to Mars, and of driven people, and the crew size is exactly what would be in Mars, and we'd be attempting to get a science program done under sim conditions. So it is quite different.
It's different if you look at a continuum from what they do in Antarctica, valuable work, not only in terms of earthbound science, but human factors. And then you swing on the other end to the Mars 500, because in Antarctica there are some of the dangers. They don't go out the way our team will, but their danger level is much higher, as opposed to the Mars 500, where there really wasn't. The danger was just that they were bored to tears, and then they mutinied, so it was all pretty cool. So we're going to try to combine both of those things both of the,
We get a mutiny?
oh, am I the only one that knows about the mutiny? Hey,
Mars 500?
yeah, the Mars 500 had a mutiny.
Well, they had nothing else to do.
They had nothing else to do on their return visit. No, after they left, so you know about Mars 500, right? They went to Mars and they spent a month on Mars, which was a little sandbox. They got some really killer work. I'm not mocking the study at all, but then they had to come home, right? So for the last 3 months of their mission, they were, or however long, they were on their return trajectory back to Earth, and about midway home, they stopped participating. There was no sense of danger. They had done the tasks that they needed to do, and they simply stopped working. And that,
Something like that happened on Skylab. So this
yeah,
is
yes,
not unique.
Skylab had, yeah.
A day or two, though.
They said they were overworked. Yeah,
Yeah, there was a mutiny on Skylab.
yeah.
But in the back, sir.
Earlier, you mentioned that the snow could be a problem in terms of geological analysis, and that makes sense. But what I was wondering, Mars is a pretty dusty place from all the pictures I've seen. I mean, obviously I've never been there, but it seems pretty dusty. Is it possible that that snow could act kind of analogous to the dust and might actually provide an opportunity to solve some problems that we otherwise might not have foreseen in regard specifically to geology? There may be some very important formations that are covered up by Martian dust, and we simply wouldn't know about them.
Well, in that sense, but there actually is dust on Devon Island during the summer, and it's like real dust, okay? And so in terms of dealing with dust problems, in terms of what it does to equipment and so forth, we'll be dealing with them in real life as dust. Snow does not behave like dust. Snow does not migrate into the HAB and get into your microscope and ruin things in that way. Now, in terms of, as you say, covering geology that you might be interested in, yes, it is an analog in that sense, but it's a certain problem. So we may have to alter the science tasks in the winter time to deal with the reality of the situation that we have. And, my position is if you got lemons, you make lemonade, okay? And if it's dark 24 hours, do astronomy. The total annual snowfall is not that great. It's actually precipitation, for instance, like a quarter of that in Aspen, Colorado. Okay, but nevertheless, it will cover the terrain, and while you can penetrate through it and do certain things and do sampling of certain kinds, you won't be able to do geological exploration of the same kind that you can in the summer.
And
But
they'll
you can
have-
do lab work.
You can do lab work. There's going to be a lot of human factor studies that'll probably be more focused during the dark time of the year. So they'll be busy.
That's in the back.
Derek?
It seems to me that you've got two different sets of problems here. So there's the crew disconnect issues that you've been talking about in the science back room, and the human factors and the boredom. That's kind of one group. And then the other group is these logistical cost safety issues associated with actually being at Flashline, which is obviously really hard to do. So why not do a year at MDRS where you can concentrate on the stuff you can do at MDRS, which would be the boredom, the human factors, the doing the science, getting the crew right, picking the right people and all that. And then if that works out, you can go concentrate on Flashline and do a year there, and it won't cost as much to do it at MDRS, and it won't be as more difficult, and it'll be much safer. I'm just wondering if that's been considered.
You're going to encounter a lot of the same logistical problems if you go to MDRS and do a one-year mission because of the same kind of climate issues. And then you have a whole different set of issues, not so much related to its remoteness, but actually its non-remoteness. So that could be an argument, but also MDRS is just way sexier, so we should go there.
I mean, Flashline.
I mean, Flashline is just, you know, it's a way, come on. I mean, I've been both to FMARS and to MDRS, obviously, and people are way more impressed that I've been to the Arctic than I've been to the Utah desert. So.
Right. Well, that's put somewhat facetiously, but there's a deeper truth behind the somewhat casual way she posed it. Okay, no, really, if you're at MDRS, you're not isolated. I mean, you may choose to stay at MDRS and act as if you're isolated, but in the same sense that the crew in Mars 500 was never isolated, because if there was ever any issue, you could walk out the door. Okay, if you're at MDRS, if there's any issue, you could hop on an ATV and be in Hanksville in 20 minutes. You could even walk to Hanksville in a couple of hours. Okay, okay, so you don't have that aspect. Now there is some, I mean, there is some merit to what you said. I mean, I did think about it. Okay. Because certainly the logistical costs would be much lower in Hanksville than there's no comparison, okay? And the risks would be lower, and it'd be tough to do a one-year mission there because of the extreme heat in the summer, but you could do a 10-month mission there. But it's worth thinking about, but at this point, we have committed the MDRS to these 2-week rotations, which I think are extremely productive, not only in what we're learning, but what the people who go there are learning, okay? In other words, we've had 800 people there. Now, some of these sims have been excellent, some have been good, some have been fair, and some have been bad, okay? But the large majority of people that go there come back with some lessons learned of their own, some insights as to what is likely to be practical on Mars and what isn't, okay? And many of these people end up in the space industry or at NASA or at universities or somewhere where this insight that they have can come to bear and thus guide their activity and their
That's actually a really good point. That I think that MDRS crews mostly are students, and that the longer duration crews, like the Flashline 4-month crew, this has been a really important career building experience for those people, and they have, because of having had that experience, they have redirected their careers really to focus on analog research or, you know, be much more embedded in space research. And I think that's going to be true for a 1-year crew as well. I mean, this ends up being a big resume item for getting in the astronaut corps, for applying to be in the Mars crew, for applying to be on Inspiration Mars. It's a big career builder.
Right. And then there's finally one other thing here. Well, there's several other things, but I'll mention one, which is this. Okay, we've heard about Inspiration Mars. I think they have a fighting chance of making that happen, okay? But they may or may not. We have, we're going to do everything we can to help them, but there it is. We're going to hear about Mars One on Sunday. That's a very exciting project, but most people will consider that a more remote possibility of coming to fruition. This is our Inspiration Mars. Okay, this is our shot heard around the world. Okay, one thing that was very interesting to me about Mars 500 was the immense worldwide attention that it got, despite all of its limitations that we have discussed. The fact of anyone doing anything that was advancing the ball down the field towards humans to Mars, you know, this got worldwide attention. Now, this mission is so much more of a realistic and intense rehearsal of a human Mars mission than Mars 1. That it's 2 orders of magnitude more impressive. And I believe that if we can do this mission, and this is going to be very challenging to us to do this, okay? I told you what the schedule is. That's a plan. A lot of things have to go right to pull that off. I think we have good chances, but we're going to have to really extend ourselves to do it. If we can do this, this will focus the attention of the world on the challenge of Mars, okay? And it will make the human exploration of Mars sensuous to billions of people. I mean billions. I mean, because it will be covered by media that will reach billions of people. And this is our attempt to set the agenda. And it would simply not be the same if we did it at the desert station. So I believe we're just about out of time. Claire, you can get the last question in. This better be a good question, because we're postponing the movie because of you. Okay.
Shouldn't we keep in mind the fact that Mars is cold, and that has effects on equipment and all? But the other one is your sim going to include the kinds?
Please use the microphone.
I'm sorry. First off, shouldn't we keep in mind that Mars is cold, and that has different kinds of equipment issues, I think, than hot? But the other one is, are you planning in your sim to include the kinds of media attention and contacts that a real Mars mission would have?
Well, yeah. As I said, outreach is there as a priority right after actually conducting the science program. And so we will have communication from the crew to media, okay, in an organized way, not in a way that totally wrecks the mission by overwhelming, but we will have contact with the most important media that becomes available. There is also the possibility that we will get an embedded reporter with the crew, okay, from an organization that may help fund the mission. Okay, we are in discussions with some people about that. Now, if we do that, that person will be a member of the crew, okay, but they will also be able to report. And in that way to communicate the experience of the mission to millions of people outside of the mission.
I'm under the impression that some of the NASA crews found it irritating and annoying and interference with what they thought they ought to be doing.
Some people do, and it has to be controlled because it cannot be let to be overwhelming. But look, this is an essential part of the mission. We're not going to get to Mars by analog activity itself. What? The question is, there are some people in some previous MDRS crews that have objected, in particular some NASA crews, that have objected to media involvement. Now, in some cases, they were actually correct because there were certain crews in which media involvement got out of control. But as a general position, it's not correct, okay, because we do have to have contact with the media. Okay, as valuable as analog research is, it won't get us to Mars. Winning the battle of ideas will get us to Mars, okay, conveying the importance of humans to Mars to the public. Okay, that's what's going to get us to Mars, and that's why we must have some media contact with this expedition. Right. Anyway, that's got to close it. Thank you.